whether it be DC. Current setting, you may only be able to weld that between 70 to 90 amps. If you go out of that realm, you're an automatic bust. It's no longer applicable to that procedure. So this is where we start to see why I talk about the essential variables. Okay? All these things, you start changing one of them. Welding technique, for example, whether it be a stringer bead or a weave bead, we're putting a lot more heat in on a weave bead. However, we're filling it up and putting a lot more iron in. Stringer bead's going to be less heat, but it might take a little bit longer to do because you're going to have more filler passes to clean and so forth. Okay? If you change any of these variables, so say the number, say the welding technique, whether it's specified it was stringer bead or only weave bead, and you change that variable, it's no longer the same procedure. It needs to have a new procedure written to it. Okay? Same thing. Diameter and wall thickness of pipe. Okay, most codes will tell you you're allowed, so for ASME, if you weld a 2-inch pipe, you qualifying 2-inch pipe, you're good for everything above and every diameter above that. However, your wall thickness is still limited. Now, if you qualify in 2-inch, a super coupon, you're allowed to go up to, so a super coupon is going to be 5/8 inch thick wall, a real heavy wall material. If you weld that out and you pass that test specifically, then you're allowed to weld up to 1.5 inches thick, from 1/8 of an inch thick to 1.5 inches thick pipe wall, any diameter. Any diameter whatsoever. It's called that's why it's called a super coupon. If you can pass it, for most common weld purposes, most common piping systems and sizes, you're going to be able to weld all of those. Okay? Root opening, everything. Position of welding. Uphill to downhill, you don't just get to choose. Okay? It's either uphill or downhill or both, but in the exact order it needs to be. You don't just get to start choosing and say, hey, I'm going to weld this downhill or uphill. Now, if there's no code, if you're not welding the code, then yeah, you can change the majority of this. But if you're on a job and you're welding to a code, you have to follow that procedure. Okay? And that is important, crucially important. So many people go out there and they think, well, I'll just weld it the way I've always welded it. No. You're no longer following the procedure. You can, and more than likely, you're guaranteed to get fired by doing that. You have to follow the procedure in order for the insurance company to cover it. Okay? Now we come back to the procedure qualification test. So what we're going to do, as a CWI, say somebody sends me, say an engineer sends me a procedure, WPS, a welding procedure specification. Okay, that's the spec. That's the procedure. Then what I need to do is create the PQR. So that's the procedure qualification. This is a test, but I'm going to record it. So it's called a procedure qualification record. Okay? So I'm going to follow every one of these variables right here in this procedure. I'm going to make sure that the welder's doing it, or I'm going to do it. Make sure everything aligns. I'm going to record it. I'm going to time you. You weld one welding rod. You're going to start welding. I'm going to start the stopwatch. You're going to weld, say, 4.5 inches in 45 seconds. I stop the top stopwatch. I measure how far your weld is. I'm going to put that in. We're going to calculate the heat input. I have to record that and put that in the values of the procedure qualification record. Okay? So the WPS says this is how we're going to do it. The procedure qualification test means I'm going to come back and I'm going to prove that the mechanical properties of this weld are compatible. Okay? The mechanical properties are able to be joined together, it's able to be welded, and they're compatible. There's not a problem with that portion of this. Okay? Right here it says it establishes the fact that procedures can produce welds having suitable mechanical properties and weld soundness. Again, we're not done yet. Weld soundness depends on the welder performance as well. But if the welder performance is good, it should be a sound weld. Okay? Now, we go up here to the code welding. So what the next step is going to be a welding procedure qualification record, or a test. So now it's called a WPQR. Okay? Now what that means is that you physically performed that weld within the guidelines of the procedure. Okay? So, WPS, Welding Procedure Specification. I'm going to abbreviate it. I recommend that you write this down so you know it. This is the procedure. These are rules to follow. Okay? Or this is your recipe. All right? The PQR. This proves mechanical compatibility. Okay? Procedure qualification record. Now, the welder performance qualification record means that the welder performs the weld to code specification. Or this is a sound, good weld. Okay? I would make sure that you write that down and you understand the three very well. Now, a lot of times there's a difference between a tested or qualified welders versus certified welders. So let me clarify this real quick, okay? You can take this test, the Welding Performance Qualification Test. If you produce this weld applicable to code standards, all right, then you are a qualified welder. That means you are able to do this. Now, once we are done with that, then what happens is, so for example, me as the certified welding inspector, I will write the papers to document it. Okay? So I'm going to switch over here. Qualified is the ability to weld it. It means you passed it. Certified means that now the inspector or the qualified person has written you the correct documentation to prove that you are a certified welder. Okay? All right. Okay. Certain changes can be allowed. However, typically most companies and most insurance companies are very hesitant to do that. Right, here's your essential variables versus your supplementary essential variables, non-essential variables. Those in which change is considered to affect the mechanical properties of weldments and shall require a requalification of the WPS. Okay, so that means if you change this, so for example, say the material, the pipe, the material that you're welding from an X52 to an X42 or from an X52 to an X72, it's an automatic, it's an essential variable, you have to requalify that procedure. You don't just gonna keep welding on it, okay? Supplementary essential variables. This is an addition. They're required for metal, which notch toughness tests are specified. So this comes into play when you start seeing a drastic temperature change, okay? Something where the service condition is gonna see 250 to 300 degrees versus sub-zero on an outside temperature to where you don't want your grain boundary to shrink, create fatal fatalities or safety issues due to elements changing within the weld and the metallurgy. Okay. Non-essential variables, those in which can change but be made be made in the WPS qualification. So usually what happens is they'll give you a range on the procedure, okay? So say the size of electrode that you're using, whether it be, they may tell you 3/32 inch diameter up to 5/32, and then give you a range. You can use those three different sizes, so 3/32, 1/8 inch, or 5/32. If it was 5/32, and then it may say you can go lower, those are non-essential variables. However, they usually give you a range, and there's a certain way you can go. So if you weld with a larger size, then typically you can go lower. However, more heat input for the larger electrodes. So therefore, if your procedure states 1/8 inch is the max, you cannot go to a 5/32 inch diameter electrode on your welding rod. Okay, then that's considered, the heat input changes, the metallurgy, then it becomes an essential variable, not just a non-essential. Okay? And I know this is a ton of information. All right, so here's the location of the test coupons to be removed for a procedure qualification record. Okay? This is an API standard. So we talk about essential variables. Let's look here. Over 12 3/4 inch diameter. Now, if it's under 12 3/4, we won't have to pull as many of specimens. Okay. So this is 14 inch pipe, or most typical say 36 inch pipe. 24 to 14. Let's go with that. When I'm done welding this, I'm going to have to pull 16, I'm going to have to cut out 16 different coupons and test them. Okay? As you can see, this has got a rut bend, a face bend, face, rut, face, rut, face, rut. So right there alone, I got 2, 4, 6, 8 welds, 8 bends that I have to make out of this pipe. In the shop, we only do 6 inch, you're only going to make 4. Now, all of a sudden, I've got 4 times as many, okay? 2, 4, 6, 8, and twice as many, sorry. We're getting to it though. Now this right here, this nick brake, this is specific to an API 1104 alone. So where we take it, we put a nick in it in the center of the weld, and we pull it apart to see if the internal parts, specifically slag along the hot pass, is present within that weld. So now we just picked up 4 more tests, right? Whoa. Then we're also going to take a tensile section. So what they do is we're going to put it in a tensile machine. We're going to measure how much force it takes to pull apart. Okay? Now it also has to break outside of the weld zone, and it has to, if it does break within the weld, the pressure it breaks at has to be at least above the tensile strength of the pipe. See the essential variables? And there's a ton of this stuff. So now, instead of 4 that we do in the shop at 6, now I have 16 coupons that if any one of them fails, I fail. So a lot of times, people don't understand. They'll go in there and we'll do our plates, and you're going to pull out 2 coupons. When you get into production welding and high production welding, usually if you're doing this, you're going to be paid very well for it. But every time you pull on a job, you have to do this test. And you got 16 coupons that have to pass. Okay? Not half of them, not 70% of them like we get here in class. Was a production code welder, every one of them has to pass within 1/8 of an inch. So that's 16 coupons. It's a lot of stuff, a lot of pressure too. Usually your job is directly tied to making sure that you can pass that weld. That's an API code, pipelines and so forth. Yeah, they don't want anybody just welding on chemicals and so forth, or on piping that's carrying chemicals, all right? Okay, so removal of test specimens. This one's an ASME, or this is also an AWS. This is for a procedure qualification record as well, okay? This is when your wall thickness gets higher than 3/8 of an inch. So right down here, when we start dealing with codes, then there's an old saying that the details are in the fine print, right there. Order of removal of test specimens from welded pipe. For pipe over 3/4 inch thick. May be used also for pipe 3/8 to 3/4 inch thick. So less than 375 wall, we can still do a face and a rip bend. But once we go above 375 wall thickness, now we have to start doing side bends because we're putting a severe amount of stress on the weld by doing a face and a rip bend because it's no longer applicable. All right? So these are side bends. They're 3/8 of an inch wide, and then we're going to bend them sideways. So that way we can see the entire weld profile. Both groove faces, fusion faces. So we're going to get a good example of the entire weld instead of just the face or just the root. Now the thinner we go, the thinner material, when we bend the face or the root, we're going to see those, they've engineered it, they've spec'd it. You're going to see the discontinuities usually show up in the thinner material. Once you get thicker, they can be hidden, okay? So there's kind of like a cushion in there. So once you're above 3/8 of an inch thick, now we start doing side bends so that we'll see any interior discontinuities as well. Now this reduced section tensile, this is where we machine it down to a specified distance and we put in the values and we make sure that it breaks at the correct pounds of force, pressure, and everything else. We'll get into that through weld inspection and quality control, okay? But this is the beginning portion of where you have to start understanding how codes work, why test specimens are there, and why have you bend them in a certain order. So here's a good example. This is what we do in the shop. This one's for the procedure qualification record versus the welder performance. Same as this. For a welder performance, we don't have to pull the reduced section tensile, we just have to pull the 4 side bends, okay? For welder performance, we just pull these 4. Procedure, same thing. We have to check the mechanical properties of it, making sure the tensile strength of the weld is still meets or exceeds the tensile strength of the material that has been welded, okay? So as you can see, they're in very specific pieces in a 6G, 5G, 2G. Your face bends are opposing each other, your root bends are opposing each other. So this is a 5G pipe, this is your top half, this is your bottom half. So you've got overhead and a vertical root, overhead and a vertical face. You've got a flat and vertical root, flat and vertical face, okay? They feel that if they, by setting these at a specific point, you were getting a good range of abilities, of a welder's ability. Tensile test specimen. It may be machine or oxygen cut, preferably flame cut usually, okay? And then we can break it from there. Now this is not a reduced section tensile, this is a full strength tensile. So we don't touch anything. The weld reinforcement should not be removed on either side. You pull it apart. This is API code, okay? Pull it apart. It has to break in the base metal, or if it does break in the weld, it needs to exceed the tensile strength of the pipe, and also there cannot be any physical or any visible discontinuities within the weld where it broke. Here it gives you discontinuities, so a 1/2 inch distance between the two. There can only be 1/32 deep, max length of 1/8 of an inch, or half the wall thickness. So, Schedule 40 pipe, depending on what wall thickness, let's say 6 inch, we're at 0.280. So half the wall thickness would be 0.140. 1/8 inch supersedes, it's a lot more strict. Since it's 125, we adhere to the 1/8 inch. Now say we're at Schedule 10, say, I want to say it's like 150, let's use 150. So then half of our wall thickness is 0.075. So now we're down to a 1/16 of an inch, roughly, okay? The thinner the wall, the thinner the material, the thinner the issue, okay? And that's in your tensile. Your prep, I will show you. You can also go to consult table 16.5, 16.4, and 16.5. It will tell you what is there. Let's look at that real quick. Okay. So just so that we're clear on a few things. Okay, we're going to look at the ASME section 9 right here, okay? So here's the thickness of the test coupon. So what we're doing in the shop is we're going from 3/8 of an inch. So we're right at 3/8 of an inch, so we're less than or equal to 3/8 of an inch. The range of thickness of base metal qualified, 1/16. The max is 2 times the thickness, so if you pass in 3/8, you're qualified to 3/4. The thickness of the deposited weld metal is 2 times the thickness. Okay. How many bends should we do? So for a procedure, this is a PQR for procedure qualification, not welder, but procedure. You have to pull 2 tinsels, 3 side bends, 2 face bends, and 2 rut bends. Now, you notice these are in parentheses. I told you the fine print gives you the detail. Okay? So it says that 4 side bend tests may be substituted for the required face and rut bends when the thickness is 3/8 of an inch and over. So, as you can see, reading technical documents is an everyday thing as a code welder. You do get to where you start to understand them. However, it can be very technical information. All right, welding qualification tests. We're going back to that. Okay. I wanted to explain all 3 real quick to you earlier, so that way you weren't kind of wondering. So now you kind of know. We're going to talk about the welder qualification, or WPQR, or now, all right? The welding, the certification test, most people call it. I'm going to go take a cert test. Again, qualification means you physically do it. Certification means you have papers for it, okay? Same weld, same material. If it passes, the only difference is you get the documentation, okay? So these are the tests that the welder's asked to perform and pass within the applicable code. Once you read through this, table 16.8, figure 1640, this is a good chapter to where you start understanding why we do what we do, okay? Why I'm having you pull test specimens and so forth. You can read through this. I'm not going to get too much in detail. We're starting to get into some really advanced stuff here. Nick break specimens from the same 2 specimens from each 2 welds. So these are in socket welds,